Alright, in this video we're going to go over the June 2014 Algebra 1 Regents exam. The best way to prepare for the Regents exam is to actually complete Regents style questions yourself. So in the description below I've left the link to this exam and you can download it, complete it yourself, and then come back to check your work, or you can just follow along with us. So let's go to the first question. So the first question says, when solving the equation here, Emily wrote the following equation here as her first step. Which property justifies Emily's first step? So in order to determine which of these properties applies to her first step, let's actually see what happened between the original equation and Emily's first step. So here we have the original equation, 8x squared plus 7, and then it became 4 times 3x squared plus 2 equals 8x squared plus 16. Okay, so what changed? So first we're missing that minus 9 that we had in the original equation, right? That's not there anymore. And we also not seeing this plus 7 anymore, right? Instead we see plus 16. So what actually happened here is we added 9 to both sides. When you add 9 to the left side of the equation, these 9s go away. When you add 9 to the right side of the equation, this becomes 16. Okay, so now that we know what happened to the equation, let's see which one of these properties applies. So let's start with the first one, the addition property of equality. That property just tells us that if we add the same number to both sides of an equal sign, those two sides of the equal sign remain equal to each other, which is exactly what we did here. We added 9 to both sides of the equation, and the left and right side of the equations remain equal to each other. So that's exactly what happened here. That is the correct answer. But let's look at some of these other ones. So answer choice 2 is the commutative property of addition. That basically just tells us that the order in which we add things does not matter. So A plus B is the same thing as B plus A. But that does not apply in this first step here. So that's out. Option 3 says the multiplication property of equality. Here we did not do anything with multiplication, right? We just added 9 to both sides, so that would not apply. And then for answer choice 4, the distributive property of multiplication over addition. Again, we did not do anything with multiplication, so that one is also out. So the correct answer for number 1 is choice 1. Let's look at question number 2. So officials in a town use a function c to analyze traffic patterns. C of n, that's how you would say that. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. Okay, so here C of n, think of that as your y, right? If we had an equation like y equals mx plus b, C of n is just our y term. And here they told us that n, we could just call that our x term. So n is what we're plugging into the function to get c of n, which is our y here. Okay, so think of the coordinate plane where you have your y-axis and your x-axis. The domain is just all the possible x values that your function can take. In this case, our x is equal to our n here. Okay, so in the context of this problem, which one of these answer choices would be the most appropriate domain? Okay, so let's think about this problem. So what's going on our x-axis is n. And what's n in the context of this problem? N is the number of observed vehicles. So let's think about that for a second. Can we have negative vehicles? Can we have a negative amount of vehicles? Does that make sense? And can we have fractions of vehicles? Would that make sense in this problem? Do fractions make sense? Okay, so in answer choice 1 and 2 we see negative numbers. In answer choice 3 we see fractions. So if we say that those do not make sense in the context of this problem, we can eliminate those right away. So does it make sense to have a negative amount of vehicles? We would have to say no. We would either have vehicles or we do not have any vehicles. We cannot have a negative amount. And can we have fractions? That also would not make sense. We cannot have a fraction of a car. We either have a whole car, 2, 3, 4, 5, however many number cars, or we have 0 cars. We cannot have a fraction of a car. So that would not make sense either. Okay, since we cannot have negative amounts of cars, 1 and 2 are out. Since we cannot have fractions of cars, 3 is out, which leaves us with 4. 0, 1, 2, 3, all whole numbers. Okay, so for question 3, if a is equal to 3x squared plus 5x minus 6, and b is equal to negative 2x squared minus 6x plus 7, then a minus b is equal to which one of these? Okay, so here we have, I'm going to write this out, 3x squared plus 5x minus 6 minus, and in order to not mess up our signs, we're going to put this in parentheses, negative 2x squared minus 6x plus 7. Okay, so the easiest way to do this is to first distribute the negative sign to each of these terms, and then it just becomes an addition problem. So if we distribute the negative, we can just rewrite it as an addition plus and then the distributed terms. Okay, so when we're distributing, we want to think of this negative sign as multiplying everything by negative 1. So first thing, negative 1 times negative 2x squared, that would just leave us with x squared. Negative 6x times negative 1 just leaves us with plus 6x. And positive 7 times negative 1 leaves us with a negative 7. Okay, so now that we have this, now it's just combining like terms. So 3x squared plus 2x squared leaves us with 5x squared. 5x plus 6x leaves us with 11x. And negative 6 plus negative 7 leaves us with negative 13. Okay, so now which one of these answer choices matches what we just calculated here? 1, no. 2, yes. We have the exact same terms. We have 5x squared plus 11x minus 13. Perfect. So 2 is the correct answer here. All right, let's look at question 4. So we're given two inequalities and we're asked to select which one of these is the graph for the set of inequalities. Okay, so let's see what we have to do here. First, we want to match up each of these inequalities with the lines that we see here on the graphs. And in order to do that, we should rewrite these all in y equals mx plus b form. That would be easiest for us to identify. Okay, so let's start with the first inequality. So that's y plus x is greater than 2. We just want to get the y by itself on one side of that inequality. Again, this equation has an equal sign, but we can just think of each of these inequality terms as the equal sign. Okay, so in order to get y by itself, we can just subtract x from both sides. Leaves us with y is greater than 2 minus x. Okay, perfect. We have y by itself. Let's look at the second inequality. So that one's actually already in the form that we want it to be in. It's on one side of the inequality by itself, the y is. Okay, so here are two inequalities. So one thing to point out here is when you see just a strictly greater than, like we have here, greater than symbol, or a less than symbol, when you actually draw the graph of that inequality, you have to draw it with a dotted line. The dotted line means it's greater than or less than, but not equal to any of the values along that line. And then when you do have a greater than or equal to or less than or equal to, you draw that with a solid line. Okay, that you need to know. So let's look at our answer choices. Answer choice 1 and 2 do not have any dotted lines, and we know that one of these is dotted, one is solid. Okay, so those are out. They don't have a dotted one. Okay, so let's look at answer choices 2 and 4. Okay, so in each of these, the same line is dotted and the same line is solid. So we can safely assume that the dotted line represents the first inequality that we have up here, and the solid line represents the second inequality that we have here. Okay, so for the first inequality, which is our dotted line, it tells us that y is greater than. So when it's greater than, you shade above that line. And that's what we have on option 2. We have shading above that solid line, that dotted line. In option 4, we actually have the shading below. So option 4 is out. So that just leaves us with option 2 as our correct answer. Just taking a look at the second inequality, y is less than or equal to, so the shading should be below the dotted line. Sorry, below the solid line. And that's exactly what we see in option 2, shading below the solid line. Okay, so let's go to question 5. In question 5, which value of x satisfies the equation? Okay, so here we're just solving for x, and let's see how we do that. So first thing that we should do is distribute out this fraction. The reason we're not plugging it directly into the calculator is because if you plug these into the calculator to turn the fractions into decimals, you're going to get a run-on decimal. And here we cannot approximate, we can't round because it would give us the wrong answer. So we have to keep the fractions until we get a fraction that would give us a decimal that doesn't end. And you'll see exactly what I mean in a second. Okay, so when we distribute that 7 over 3 out, we get 7 over 3x plus 7 over 3 times 9 over 28, all equal to 20. Okay, so now we have to multiply 7 over 3 times 9 over 28. And when you're multiplying fractions, you can actually multiply straight across, meaning we can write another fraction that's just 7 times 9, which is 63 as the numerator, and the denominator would just be 3 times 28, which would give us 84. Okay, so now everything else just comes down, stays the same. We haven't done anything to it. Okay, so now let's actually see, does 63 over 84 give us a nice decimal, or does it give us another run-on decimal? And in this case, 63 divided by 84 is equal to 0.75. So that's a nice clean decimal that we can actually just use as a decimal. Okay, so now we still have the x to solve for. So here, easiest thing we can do is subtract 0.75 from both sides. We're trying to get x by itself on one side of the equal sign. That will tell us what x is. So when we subtract 0.75 from both sides, we get 7 over 3x is equal to 19.25. Okay, so let me just bring this over here. Just rewriting the same thing over here so we can continue to work on it. Okay, in order to finally get x by itself, we can multiply by the reciprocal of 7 over 3. The reciprocal is just that fraction with numerator and denominator inverted. So the reciprocal here would be 3 over 7. We multiply both sides by 3 over 7. Okay, so when you multiply 3 over 7 times 7 over 3, right, the 3 cancel out and the 7's cancel out. So you're just left with x is equal to 19.25 times 3 over 7. And you can just put that in the calculator and you will get 8.25, which is answer choice 1 here. Okay, so we're going to go through questions 6 through 10 in the next video. If this video was useful, leave it a like, subscribe, and follow us for more videos on the Regents exams, not just in math, but also in science.